Okay, we're just going to do a quick tutorial to remind ourselves about how to do Henderson-Hasselbalch problems. And we're going to start with our equation. Remembering that X is going to be the ionized drug over unionized drug if we have an acid, like a carboxylic acid. It will be the reciprocal unionized over ionized if we have a base, like a secondary amine or something of that nature. So let's do a couple of drug examples. First, an acidic one. So if you look up the structure of ketoprofen, you'll find a carboxylic acid functional group, and the pKa of that functional group is 3.88. Now, if you're wondering, say, what is our ionization status in the stomach, so a pH of 2, we would just put all this into our equation and start solving for X. Okay, you should have a function on your calculator to do the inverse log. And so you come up with this 0.013. Remember that every number by default is going to be over 1 unless otherwise designated. And so what this tells you is that the denominator is bigger than the numerator in this case. And you can translate that because this is an acidic drug, and that is that ketoprofen is primarily unionized in this condition. And that should make sense because the conditions are more acidic than the drug itself. So mostly unionized. Okay, let's try a basic drug. So I talk about the drug midazolam. In this section, this is one of the benzodiazepines that is used in epilepsy, and you can absorb it in the cheek. And so its pKa is 6.15. And it's actually a basic drug, so you can tell by the pKa that's a fairly weak base. But if you're talking about buccal administration, we're talking about a pH of the environment of around 6.8. And so when you put all this into your equation, if you want to know what the ionization status is, once again, 6.8 equals 6.15 plus log of X. Start solving for your X. 0.65 equals log of X. X equals 10 to the 0.65. And that's going to translate to 4.46. 46. Remember, that's also over 1. So once again, the unionized form is bigger than the ionized form. This is also mostly unionized. And so that tells us that the absorption for buccal administration for midazolam should be good. All right, you're going to use this skill today in our in-class exercise, and so I just want to give you a quick chance to review. If you're wondering about how to tell whether or not the drug is acidic or basic, you're looking, of course, for certain functional groups that designate that. You can also sometimes tell by the pKa, but as you can see with midazolam, that pKa is lower than 7, and you wouldn't always expect that to be basic, but in this case it is. All right.